Welcome to the Bourns Transient Current Suppressor product training module. The objective of this presentation is to provide an introduction to Transient Current Suppressor High-Speed Protection, or TCS HSP products, gain an understanding of product characteristics, and discuss product applications. After a brief description, we'll look at the TCS HSP device's ability to limit current along with its other characteristics. We'll look at TCS HSP packaging and discuss data from various testing. Finally, we'll cover a Gigabit Ethernet application. This family of dual-channel devices was designed to provide a current-limiting function, as well as voltage isolation between a voltage-limiting device, such as TVS diode, and the circuit being protected. There are 3 current-limiting levels available, and they're packaged in dual-channel configurations. A TCS HSP device exhibits a behavior with current that is analogous to the behavior of a TVS diode with voltage. A TCS HSP device holds current relatively constant as voltage increases, whereas a TVS diode holds voltage relatively constant as current increases. In a similar manner, a TCS HSP device has a maximum voltage capability rating, while a TVS diode would have a maximum current capability rating. This curve was generated using a 1 volt per microsecond slew rate ramp. This provides a good description of how the device will behave under transient conditions. Note that as the voltage across the device is increased beyond the current trigger threshold, the current through the device will slowly increase. This is analogous to the voltage across a TVS diode increasing as the current through it increases. All TCS HSP devices are manufactured in a DFN package, with the length of the device, B dimension, directly related to its trigger current rating. Bourns TCS HSP devices behave like a resistor with a low insertion loss up to the frequency of 6 GHz. During a surge event, the TCS devices act like current limiters, protecting sensitive electronics downstream without sacrificing system performance. The 3 different current limit rated devices all show a low insertion loss to 6 GHz. The surge duration capability of the TCS HSP family of devices is well beyond the waveform durations of all of the transient surge standards. For the model TCS DL004-250-WH, the maximum duration at 25 degrees Celsius with 20 volts across the device is just 100 milliseconds. The maximum duration at 85 degrees Celsius with 40 volts max rated voltage across the device is approximately 7 milliseconds. A 10 by 1000 microsecond surge will not present a problem within rated limits. Surge current duration graphs are provided for all of the devices in the TCS HSP product datasheet. The voltage limiting device can be a TVS diode, a thyristor, or clamp diodes to a supply rail or ground. The TCS HSP device will limit the current into the protected device during a surge event, as well as provide voltage isolation between the voltage limiting device and the protected device. A test circuit was developed to evaluate and demonstrate the response of the TCS HSP family of devices. The graph shows the response of the model TCS DL004-250-WH device to a 1 volt microsecond slew rate impulse voltage ramp. Note that once the trigger current level is reached, there is some foldback in the current limit level. The current will then rise in a controlled manner as the voltage across the device increases. Under these test conditions, the trip current is approximately 480 milliamperes, folding back to approximately 250 milliamperes, and then rising back up to about 480 milliamperes as the voltage across the device is increased to the maximum rating of 40 volts. The model TCS-DL004-500-WH and TCS-DL004-750-WH devices exhibit a similar response, only with higher current limit levels. The diagram shows a generic circuit topology using a TVS diode for overvoltage protection. Let's evaluate this circuit using 1/2 of a model TCS-DL004-250-WH TCS HSP device. a CDSOD323-T05C TVS diode, and a 3.9-volt Zener diode to represent the ESD clamping function of the device under test, or DUT. In order to demonstrate the operation of the device in an application, the model TCS-DL004-250-WH was evaluated under surge conditions in a test circuit using a 5-volt TVS diode for overvoltage protection. A 3.9-volt Zener diode was used to represent the ESD structure of a device to be protected by our circuit. The graphs show the response of the TCS HSP device to be 1.2 by 50 microsecond voltage and 8 by 20 microsecond current combination wave. Note that the peak current is slightly higher than the test on an earlier slide, 550 milliamperes versus 480 milliamperes. This is because the slew rate of this surge waveform is significantly faster than our previous waveform's 1 volt per microsecond. The current folds back to less than 300 milliamperes. The model TCS-DL004-500-WH and TCS-DL004-750-WH devices exhibit a similar response, but with higher current limit levels. Summarizing the results of our test, we see that the voltage across the protected device is approximately 7 volts, which is 9 volts lower than the voltage across the TVS diode. We also see that the current into the protected device is quickly reduced to about 300 milliamperes after the initial peak of 550 milliamperes. This schematic shows a surge protection design for Gigabit Ethernet (GBE) application. A TVS diode is used as the voltage limiting device. This solution provides enhanced protection compared to a design that uses only a TVS diode. On the next slide, we'll demonstrate the difference in the level of protection. These two photographs clearly demonstrate the dramatic reduction in the current and the voltage stress level that the physical layer device, PHY, would be subjected to when the model TCS-DL004-250-WH is used. In the left-hand photo, only a 5-volt TVS diode is used to protect the PHY. We can see that the peak voltage across the differential signal input to the PHY is just over 12 volts, while the peak current into the PHY is approximately 4 amperes. When the model TCS-DL004-250-WH is added to the circuit, we first notice the dramatic reduction in the PHY input current. After the initial peak of 0.5 amperes, it quickly, in less than 50 nanoseconds, folds back to approximately 250 milliamperes. The TCS HSP device also provides voltage isolation between the TVS diode and the PHY under protection. The voltage across the differential input to the PHY is determined by the ESD protection circuit's response to the significantly reduced input current. Note that compared to the TVS diode-only design, the PHY differential input voltage is reduced by approximately 50%. The final conclusion is that the power and energy that the PHY is subjected to under this differential surge condition have been dramatically reduced when a TCS HSP device is used in conjunction with a TVS diode. We can see that the energy absorbed by the PHY is reduced from approximately 50 microjoules to about 3 microjoules when the TCS HSP device is added to the circuit. The addition of the model TCS-DL004-250-WH reduces the current seen by the PHY by approximately 90%. The voltage isolation provided by the TCS HSP device reduces the voltage level seen by the PHY by over 50%. Combining these two effects, we see a reduction in the let-through energy to less than 10%. The table above can be used to help determine whether a TCS HSP device or a TBU HSP device is appropriate for your circuit protection design requirements. The letter N in the device column designates that the device is not appropriate for the listed condition, while the letter Y designates that it is. Continuous product development enables Bourns to provide circuit protection solutions for changing market requirements. Bourns Circuit Protection TCS Transient Current Suppressor products will bring significant benefits and enhanced protection to your application. Bourns offers a wide variety of sales and support tools, and Bourns field application engineers capable of supporting your protection interface design needs are also available. Please contact Bourns at techweb@bourns.com for questions concerning TCS Transient Current Suppressor products. Visit www.bourns.com for more details.